Let's take a look at a quick example here. I want to evaluate this where E is a region that lies inside the cylinder x squared plus y squared equals 16, and between the planes z equals -5 and z equals 4. So if I try to draw a quick picture of this, see, I'm going to come out here to -4, 4, 4, -4, y, x, z. So I'm going to have this circular thing. And z equals 4. So up here somewhere is z equals 4. And z equals -5 is down here somewhere. So what I'm looking at is this cylindrical shape, something like that. Now, x squared plus y squared equals 16 tells me that y is equal to the square root of x squared, 16 minus x squared. And I need to worry about plus and minus, but I'm not. I'm going to take the positive because of symmetry. If I just stay with a positive root, then I can multiply the whole thing by 2 and get the other half. So I will use some symmetry here. But that means if I convert to cylindrical coordinates, they're actually polar right now, that y is going to be equal to the square root of 16 minus x is r cosine theta, so that's r squared cosine squared theta. And in looking at this now, I can see that my triple integral, I'm going to multiply it by 2 because, like I said, I'm going to use symmetry and only do half of it. I'll go from 0 to pi, -5 to 4, and 0 to 4. This is just a square root of r squared, which is r. So I have r times, remember when I convert over, I'm going to have an r dr, and then I went to z, so there's dz, and then this last piece is d theta. So really, I'm going to rewrite this as simply being r squared. So now I'm going to go ahead and do the integral. So this first piece, I simply will integrate from 0 to 4 of r squared dr, which equals r cubed over 3 from 0 to 4, which is 4 cubed over 3, which is 64 over 3. So now I want to integrate from -5 to 4 of 64 over 3 dz, which is going to be 64z over 3, evaluated from -5 to 4, which is 64 times 4 over 3. Minus and minus, that's a plus. So that's going to be plus 64 times 5 over 3, which if you fiddle with that, you'll get, see, 256 plus 320 over 3, which is 576 over 3, which is actually just 192. So that was part 2. So for part 3, I want to take a look at the integral from 0 to pi of simply, whoops, I've been dropping these 2's. I need to put that 2 back in. I'm going to let that 2 ride for a while. Of 192, and it's d theta. So that's going to be simply, see, 2 times 192 is 384, so that's 384 theta, evaluated from 0 to pi. So that's simply going to be 384 pi.